Hello, this is Lubomir. I work for VMware. I joined the Kubernetes project around 2017. In the summer of 2017, I started contributing to kubeadm as my primary project. I've been doing that since then. So this video is going to be about explaining to you what is the development process of kubeadm and how you can get started with it. Well, first of all, basically, this project, kubeadm, we have to explain what it does. So kubeadm is a cluster bootstrapper or also a Kubernetes deployer. So the purpose of this project is to facilitate the deployment of the Kubernetes components on nodes on your infrastructure so that you can create a Kubernetes cluster. And there are a lot of tools out there, but maintained by the SIG Cluster Lifecycle group. The SIG Cluster Lifecycle is one of the special interest groups that is responsible for all those Kubernetes deployment tools like Minikube, KEPs, kubeadm, kubespray, and so on. And kubeadm, ideally, all of those tools are going to use it eventually because kubeadm is a very low-level building block. It's a very, very low-level tool. So to quickly explain what low-level means here, kubeadm is a low-level tool, but if you really want to understand like how is Kubernetes deploying, how to connect Kubernetes nodes into a cluster, maybe you should look at the Casey Hightower tutorial that is called Kubernetes the Hard Way. And this is a Nelson tutorial, he explains everything in very good detail. But on the other hand, tools like kubeadm have exactly the opposite purpose, because Kubernetes should not, deploying Kubernetes should not be hard. kubeadm has the purpose of facilitating this process. At the same time, keeping it feasible to do low-level development. For instance, you change something in the API server, and you can still deploy your custom-built Kubernetes control plane using tools like kubeadm. And then you can join also some workers, perform some conformance tests. So this is a project that is, kubeadm is a fairly popular project. It's part of the Kubernetes release. It follows the Kubernetes release cycle, and it also follows some of the principles in developing Kubernetes. So before we begin, I wanted to do this brief introduction, but I'm now going to share my screen and show you some web pages that are important for the kubeadm development. All right, so this is the first page I wanted to show. This is the under Kubernetes community, and this is the Cluster Lifecycle Special Interest Group page. In here, you can see all the different projects this SIG is maintaining, and one of them is kubeadm. So we do meet every Wednesday. This is roughly like 5 p.m. Universal time. You can convert your time zone. You can see our agenda nodes. So this is basically a Google document that everybody, I'm going to explain who can view this, but you can join. So this is a document that we use for pretty much orchestrating our Zoom meetings. So we are using Zoom for the meetings. And the way this works, we pretty much add a list of attendees, like everybody should add their name here. And we also have agenda. And the agenda, basically in the agenda, we introduce new participants. We show some PSAs like, hey, there's a massive bug in Kubernetes, let's fix it. It also affects kubeadm. And then in the agenda itself, we have a list of people and their topics. Like for instance, Fabrizio here in the square bracket is talking about something about etcd and the joint control plane command. And if you want to add the agenda items, you can just open this document and add your name and your topic that you want to discuss. We also occasionally do backlog grooming. So this is like going through the pending issues and PRs, and we just assign people who want to work on that, and we also like close issues that are already fixed. So this is the agenda document, but you have to also join our mailing list. So this is the SIG Cluster Lifecycle mailing list, and it's a regular Google group. So when you open this page, you're going to see a join button here. You can click it in. You're now following the SIG activity. Once you have that, I'm pretty sure you're going to be able to view and edit this document. All right, so what else do we have from this page? Apart from having all the meetings and agendas for the different projects, we also have a list of existing recordings. I believe these should be YouTube playlists. Yeah, so this is also the entire activity of the SIG. We have everything as a recording here, but you can also see previous recordings of the kubeadm office hours. Like search for those, and you're going to get an idea like what are we talking about during these meetings. And some of those can be really, how do I say this, like technical, but once you start understanding the code base and like what is the behavior of kubeadm and what is it doing, and also once you start following our issue tracker, you can pretty much start understanding what we're talking about. It's not, essentially, it's not rocket science. So let me close this page, and now I'm going to show you why kubeadm is bound to the Kubernetes release. So if you go to Google and type something like KEPs 117, you're going to get information from this page about the current release. So kubeadm follows the Kubernetes release cycle. Kubernetes has a new minor version every 3 months. So this means that when Kubernetes 117 is going to be released, there's also going to be a kubeadm version 117. And this binary of kubeadm is going to be included in the official, I believe, the node, the Kubernetes node turbos for Linux and Windows also. So this is a page maintained by SIG Release. That's another SIG. Obviously, what they're doing, they are responsible for the release process of Kubernetes. But what I wanted to show you here is that there is a table here, and this is the schedule of the release. So the kubeadm maintainers, like, we look at this table and see, okay, we have to, adapt our plan for what features and whatever we are going to add in this release based to this table. So this table, for the 117 release in particular, a very important date for us is like enhancement freeze. That's the first one. And I'm going to talk about what is enhancement freeze if I open and show you a certain repository. So this is the Kubernetes enhancements repository, and it has a very interesting purpose. So Kubernetes itself has become so complex over the years that whenever we want to change something, we have to submit a proposal. So the way this works is like, first of all, we have to log an issue in this issue tracker. So create an issue, and an issue looks like this, and it has a template, like it's an enhancement proposal, and then we say like, when is this going to be alpha, beta, or stable? And also there has to be something else, and that's a so-called Kubernetes enhancement proposal. So for those, you have to create a PR, and there's a template for those as well. But if you look at the SIG Cluster Lifecycle existing KEPs, like we have a bunch of projects here, like Cluster API, etcd, ADM, and kubeadm. And this is the list of our existing proposals. Like, let me clarify here. These are big changes in kubeadm. Normally, when you start on the project, you're probably not going to care much about this yet. But these are big proposals, like we're changing the API, or we are, for instance, adding phases to a certain command. And I'm just going to let you know about this process. If you look at it, you have to open one of these files and try to understand what it does. It has a pretty big template, and it explains what are we going to change. It has sections like goals, motivation, proposal, user stories, implementation details, like how is this going to work even. We have a test plan, graduation criteria, examples. It's a pretty detailed proposal. So a KEP means Kubernetes enhancement proposal. We do this as kubeadm is still using this process of defining extensions. or which can be changes or features in general. Going back to the enhancement freeze topic. So by this particular date, we have to be done, and we have to be merging, we have to be done with merging all these new enhancements proposals. So we want to change kubeadm to behave in a certain way. You have to submit this PR for this new file in here, and then basically this has to happen before the enhancement freeze has landed. So this happened on October 15. For this particular cycle, we already done with our proposals to enhance kubeadm. And then let's look at the calendar even more. This is, you can also have exceptions for if something is not being able to land in a particular date. You can also have exceptions. That's a separate topic. This complicates our examples in this video. So another important date is code freeze. So during this time here, during the enhancement freeze and code freeze, we have a period of time where we can develop this feature. The feature has to be sent as PRs. Everybody has to be able to review this, and the PR has to be merged before code freeze. This is about features. But if something is a bug, if something is critical, we can still send PRs for that after code freeze. The code freeze is more of an enhancements, like more of a feature freeze. So after this is landed, only critical bugs can be sent to the code base until another date begins. And this particular date is called toll. And when this happens, this means that the branch of release-117 of the Kubernetes repository is now not being fast forwarded, and it's a completely separate release. And at this point in time, we have to start backporting fixes for 117. Even if the release is not out yet, we are already like backporting features, not even features. We're just backporting PRs to this old like new branch. So the next date that is super important for us is the actual release date. And there's also this in between, there's this cherry pick deadline. After this has happened, well, there is a period of like a week where we cannot even send any more cherry picks. So this is very time boxed. And this is the result of trial and error from many different, many releases of Kubernetes in the past. This is a process that is still evolving, but the release team and the SIG release believes that this is optimal for the time being. And kubeadm follows this. And actually, I'm a believer that this is healthy for the project because we are time boxed to work on these new features. We are time boxed to fix critical bugs. And we are not slacking on the development process of kubeadm. There's another date I missed here is a docs complete date. So after we did the code freeze, we did the code freeze and enhancement freeze, there is a period of time where we have to send docs, and this is the actual docs deadline. This is for Friday, November the 15th. We have to send all our docs that document new features. And then there is a docs complete date that all PRs should be reviewed, all docs PRs should be reviewed and ready to merge by then. So we have a period of like 7 days to complete that as well. So this is pretty much about my summary of the release process of kubeadm. But now let's look at some of the actually details about what we do. So I wanted to mention, like, first of all, there's this kubeadm repository on the Kubernetes, and there's also this folder CMD kubeadm under Kubernetes. So kubeadm is still part of the main Kubernetes repository, and it's being developed as part of this main repository for historical reasons for basically we have some import restrictions that we are trying to decouple. That's one of the reasons kubeadm still lives in this repository. Arguably, it's also easier to test this way. But in the near future, hopefully, we can break kubeadm outside of this repository. But now, like, I'm going to get back to this to explain some, like, briefly what is the code structure of kubeadm. But I wanted to mention that we also have this repository. So this repository, if you go and look what is the description, it says that it's an aggregator for issues filed against kubeadm. So this is like, is this the issue tracker for kubeadm? Well, the answer is yes, but also it contains some tools and also docs. The main documentation for kubeadm lives in this repository. So if you go in here, if you go under documentation, kubeadm is basically spread in some of the subpages. You probably, if you have tried kubeadm already, you might have seen some of these pages already. Like going to tasks, you can go to administer cluster. You're going to find some of our pages that we maintain. But then why do we also have docs in this repository, which is under aggregator? Well, this is these docs do not really fit very well into the main Kubernetes docs. These are like more like covering implementation details of kubeadm. Like we have a design folder, and this is slightly outdated, but it explains some of the concepts behind the original design of kubeadm. It's pretty interesting. You should definitely check these pages if you're interested in like some of the original design. So also we have pages like managing end-to-end tests, like how do we do end-to-end tests in Kubernetes, targeting kubeadm even, like how do we do it? We also have some documents, like these need some updates, but we also have a release cycle document, which is pretty much overlaps with what I tried to explain here. It's slightly more detailed, but slightly outdated. We also have test failures, like how do you debug test failures? We also have testing pre-releases. There's some interesting resources for you to basically read before even jumping to kubeadm development. We also have updating command references. This is more of a like instructional documentation here, but also some design is covered. So going back to this repository, I wanted to explain that like probably kubeadm is going to move from here, CMD kubeadm app is going to move in here. But we also have some other stuff, like we have Kinder. Kinder is a tool that we use for end-to-end testing. It's a tool for testing kubeadm deployments. It's based on Kind. It deploys Docker in Docker Kubernetes setups, and it's a tool that we use. You can check the README. This tool, by the way, we don't recommend that you use it in your, I don't know, in creating your production clusters, because this is a tool for testing. It's designed for helping kubeadm contributors by allowing them to create, delete, and modify local clusters, and also execute some actions. So this is a tool that we also maintain in this repo. Something else is we have some logos and the operator. So the operator is a work in progress. This is something that Fabrizio is working on, Fabrizio Pandini from VMware. He also is working on Kinder. He's the lead maintainer of both the operator and the Kinder projects. The operator is, you have to look up in Google what is a Kubernetes operator pattern. And it's probably going to give you an idea what we are working on here, but this is, please mind that this is like work in progress, it's experimental, should not be used in production. Maybe in the future we're going to have a release of kubeadm that is going to bundle this new feature that is the kubeadm operator. We also have some end-to-end tests. So those, I mean, it's kind of questionable if some of these should live here. But these we have end-to-end tests for manifests, and this one is in particular interesting because we use this end-to-end test to basically monitor if all the Docker images of the Google GCS buckets that we use for deploying, let's say, a control plane, are always they're always up there. They're always uploaded. So because we don't want to get all those user reports like, hey, I tried deploying the latest Kubernetes version using kubeadm, but I'm getting this missing images error. And the manifest test is exactly for testing that. We also have a test for packages. And this test is responsible for checking whether we have all those Debian and RPM packages also deployed to Google infrastructure. And this is pretty much the contents of this repository, but let's go to the issue tracker. Now, this is where like basically most of the kubeadm development happens. This is where we monitor the state of what we have done in the past and what we have to do in this cycle. What we have to do in the future. So ideally, everything should be tagged with a milestone. Like we have some milestones. Let's look what we have. So the current one is obviously 117. And then we also have some like some from the past, like 151, 616. We keep these in the repo because we might tag something for backporting using these milestones. But ideally, we should remove them, as soon as possible once like the new releases come in action. So 117, if you click at this milestone, we're going to see some issues. And those are ideally issues that we should complete in 117. But this is like a best effort. You have to understand that in open source, even if some of us are backed by companies like VMware, SUSE, Intel, we can only do as much. So basically this list is a best effort list. Like, we might, based on priority, we might complete some of those items. Some of the items are super important. We have priority labels that I'm going to explain in a bit. But basically, the priority here is that, if something is high priority, we're probably going to do it in the 117 cycle, as per this particular milestone. But if something is a bit of a stretch, like if something is with a priority backlog, we might shift this into the next cycle. Because it's not a high priority for us. Maybe people don't have the time. And we have to pretty much prioritize our work. So I'm going to show you like the list of labels that we have quickly. So there's a big list of labels, but I wanted to show you the priority labels. So these priority labels are as pretty much standard practice in the Kubernetes project. Don't buy this, needs more evidence, because it's pretty much a duplicate of awaiting more evidence. But starting from awaiting more evidence, this is like the lowest priority. Imagine that somebody logs an issue and we don't have enough information, or like from the user, maybe this doesn't really make sense for us to add as a feature. So this is the lowest priority for us. We're going to add this and pretty much keep the issue open, maybe. But we are going to wait for more evidence. Like the guy who sent this ticket, they have to convince us that this is something that we might want to address. So this is the lowest priority. The next one is priority backlog. So this means that, hey, we are acknowledging this problem, but we might do it in another release in the future. So that's pretty much the meaning of backlog. By the way, these also have descriptions on the site. So what else do we have here? We have important long-term. So important long-term is like, it can be a bridge type of issue, because what I mean by that is we might work on this in the 117 cycle if there is enough time, but if we cannot do it, it has to be moved to the next release. So it's pretty much close to backlog, but except that this one is important. So the backlog issue, hey, we might do this or not, but important long-term is something that we have to do, and it's like waiting for somebody to get assigned and work on that. The next priority is something that like it applies to this release. Priority important zone means that this is not the highest priority of the list, but it's pretty important. And we have to ideally complete this in this release. Like on a very rare occasions, we have important zone issues that get shifted to the next release. And then comes the highest priority, which is critical urgent. Critical urgent is the type of priority that, like, if we have an issue like that, like, we try to send a PR for this, like, in the next couple of days, or maybe there has to be discussion for this. It might get delayed a little, but usually this a PR for something that is priority critical urgent gets sent almost immediately. All right, so let's get back to the list of tickets for the milestone. I wanted to like quickly outline some of these items. Like there, by the way, there's a lifecycle bot in Kubernetes. You might have seen this already. So there is a bot that if an issue is open for a very long time, you know, because we have so many issues in Kubernetes, let me show you. All right, so in Kubernetes, you have like 2,000 issues and something like 1,000 PRs. This is very difficult to manage. So folks from SIG testing, in particular, Eric Feita, developed this tool that is a bot. So the bot is basically automatically triaging old issues. Is somebody, so if nobody is touched a certain issue for 90 days or something like that, the bot is going to close this PR, but it first goes through different stages. And in the kubeadm repository, we use pretty much one of these stages, and that's lifecycle active. So the different options for lifecycle, let's look at those as well. All right, so there we have to look at these, the lifecycle slash types of labels. So the first one is lifecycle active. This means that, like, okay, somebody's working on that. We added this label to Kubernetes because, for new contributors that are not yet members of the Kubernetes organization, it's very difficult to distinguish if some of them are working on an issue. You cannot get assigned if you are not a member. So I'm going to also, I guess, talk about what is membership quickly and owner files as well. But let's look at the lifecycle labels first. Like lifecycle active, this means that somebody's working on this. And then we also have lifecycle stale. Now, this is when the lifecycle bot from Eric Feita comes in. It starts marking a certain issue, like a stale issue. Like nobody's working on that. And then after a certain period of time, it removes the lifecycle stale label and it adds the lifecycle rotten label. And this means that after another period of time, the issue is going to be closed. Now, to prevent that and keep this this issue open regardless of the bot actions, you can add the lifecycle frozen label. And this means that the issue might live for a very long time because it's kind of important for us, but we don't have a good decision on how to proceed. So these are the lifecycle labels. Like, let's have a look at what else we have here. We have something like that is called a tracking issue. Like occasionally we have these tracking issues. For instance, check this out. Like we have a tracking issue for Windows support. Now this is not an easy topic to work on in kubeadm, and this is going to take a while for us to develop completely. So it's a tracking issue. It contains a number of PRs linked in there. Like, have a look at this. We have so many different PRs. People are working on that, and we use this as a tracking issue to as a hub for all those PRs that we sent. And we also have a project board by SIG Windows, apparently. Okay. So we have all these different labels. So what I suggest to you is just hover over the labels, and every label has information for you. That's one way to learn the meanings of all these labels that we add. And this is GitHub. There's no like magical way for us to distinguish between different issues apart from naming. and labels, and also the milestone. So we are users of, a descriptive name. We add everything is added to a milestone. If it's not applicable anymore to this milestone, it's going to be moved to the next milestone. And also we have, all those labels that try to qualify this issue to a particular area. But we have all these issues, but you're going to say like, hey, all of those things don't make any sense to me. Well, that's when we have special labels for new contributors. And those are a couple of labels. One of them is like help wanted, and the other one is the good first issue. So let's read the description of those. By the way, I think you can Google Kubernetes good first issue, and also Kubernetes help wanted. And there's some web pages developed by some kind folks from the Kubernetes community that basically have a very good explanation of what qualifies as a good first issue, what is a help wanted label as well. So let's read what we have here. So the good first issue denotes an issue ready for a contributor according to the help wanted guidelines. So this is kind of vague, but I want to explain to you that a good first issue means that this is something that it should be the simplest possible issue to tackle. And in this type of issue, we have to provide you with a guideline. Like it's the responsibility of the maintainers to give you a very good guideline to work on this issue. So if you see a good first issue type issue, and you don't see a guideline in there, that's it's not correct. There has to be a guide or a mini tutorial in there. So the other one is help wanted, and this is kind of this is a bit of a controversial label. We had little discussions with the SIG contributor experience folks. So help wanted is if you look at the description, it's exactly the same as the good first issue. But like, what is the difference? So according to the same help wanted guidelines, a help wanted type of issue is something that is more complex based on a good first issue, but it's more complex. And you don't have that, you don't need to add this detailed tutorial in there, but still you want help from someone. And this is where the kubeadm issue tracker is slightly different from Kubernetes, and we say like, hey, we are going to use the help wanted label if we think that like there's nobody assigned to this, but we want somebody to be assigned. So we are going to add the help wanted label and see if somebody assigns themselves. Like, let's click on this this issue from yesterday. I added the help wanted label because I thought that this is a pretty easy change. And somebody can work with that. As somebody just immediately assigned themselves, and that's already a Kubernetes member because they can type /assign. And this Kubernetes CI robot immediately assigns them. So this is an example of how the help wanted label works. We have something that is help wanted. Folks come by and say, okay, I'm going to work on that. They might ask some questions. We are going to explain to them, some details if they need them. And this is how kubeadm contributors and also Kubernetes contributors get onboarded. They start working on certain issues. They start looking at the code base, like, okay, I have a link here. Let's look what we have here. So this is not the best example, but this is like, hey, the API server has this admission plugins. Like, okay, maybe I'm going to Google like the Kubernetes docs to see what is an admission plugin, and then like, what is the meaning of this node restriction admission plugin, and what do I have to do here? So they also, after my short explanation, I basically explained that we have to add a new admission controller. Now, by the way, we haven't decided if we should do this yet, but let's see. Let's look at this as an example. So, what else do we have in the issue tracker? Well, we also have some PRs, but those are for these PRs here are pretty much fixing the end-to-end tests, the kinder and the operator tools that I showed you earlier. These are not important. You shouldn't look at these. These are like internal. We have these internal occasional development PRs for this repo. But like, how do you send your first PR for kubeadm even? Like, before you send the PR, I strongly encourage you to log an issue first. And I'm not going to stress a lot on this topic, but if you send an issue, you're going to get a response from the kubeadm maintainers within a couple of days. And if you're not sure if you should be sending a PR for this, you found a bug, but it's kind of controversial. You're already seeing that this is touching way too much. Like, send the issue, send your, send a link to your pull request in your fork of Kubernetes, and basically let's have a discussion first. If something is complicated, we're going to go to the SIG Cluster Lifecycle meeting, and you can book time during the the SIG Cluster Lifecycle meeting. The kubeadm office hours meeting. You can have an agenda item. We can discuss the issue, and maybe it's only then is going to be appropriate to send this PR, because kubeadm is a very mature project. At this stage, everything we try to touch might affect a very large group of people, and breaking backwards compatibility is something that we don't want to do. Like, every 3 months we release a new version of kubeadm, and this release should continue working for all those folks. Like 117 is released for 116 folks. It should continue to work in the same manner. And we have to keep backwards compatibility. So everything we touch, we have to follow some deprecation cycles. We have to follow the guidelines for API changes. So let me try to open some of those pages to quickly explain. Okay, so there's a page in here that I strongly encourage you to have a read of what this is about. So Kubernetes is a project that has to make some guarantees. So every 3 months we release a new version. And what if there's a feature that nobody wants to use anymore? What if you want to deprecate this feature? Well, this is where we have developed a deprecation policy. So if something is basically a feature that we want to deprecate, we have to apply the deprecation cycle on it. And here we have deprecation for API objects. We have deprecations for the COI flags. And also we have deprecation for features and behaviors. So you should definitely read some of those. But the TLDR here is that for alpha features, we can disable and remove them, without any notice. We can say like, hey, this is alpha. It wasn't a good idea. Let's remove this. As you can see, like, hey, this is alpha is being removed in 0 releases. But for GA, and please mind that kubeadm is a GA command line tool. This means that every time we want to remove something that is a COI element from kubeadm, we now have to follow the GA deprecation cycle. Unless in kubeadm we have this basically a subcommand that is called alpha, and we have this for the purpose of having like a island of features that we can use. Well, this island of alpha features that we can use to make it easy for us to deprecate stuff without following everything falling under the GA deprecation cycle. This means that we have this alpha subcommand of kubeadm. We can remove something within 0 releases, but we're still conscious about it. So we might even, apply a deprecation policy of 3 months for an alpha feature. It can be a judgment of the maintainers of how to proceed, but we are very conscious of what we are doing with the deprecation of different, parts of kubeadm. And kubeadm also has an API. This is the so-called kubeadm config file, and it's currently in beta. This means that we have to keep some of our beta objects for 9 months. And we are very conscious about deprecating individual fields, adding new fields to the API. And this just gives you an example of when you send a PR to modify the kubeadm API, it has to be, sorry, it has to be scheduled, it has to be planned, it has to be discussed. This is very serious. It's not that kubeadm is a massive project, it's just the user base is very big. So we have to pretty much comply with all those folks that are already using a certain feature from, let's say, the API of kubeadm. So let's see where we were before. I was giving some examples of what we have in terms of deprecation policy. Yes, okay, I remember. So please log an issue before sending the PR. That was my basically suggestion for you. If something is a typo or if something is a small documentation change or fixing, renaming a variable or something like that, it's fine. You can send the PR. There's no need for an issue. But if something is changing the behavior or if something is a bug, please log the issue first and wait for a couple of days. You can have your PR ready in your fork and you can just send it to the Kubernetes repository. Because like I mentioned earlier, kubeadm itself is still part of Kubernetes, and you can go to cmd kubeadm. And now let's have a quick look at what we have in this folder, cmd kubeadm. So we have, first of all, let me explain owners. And I gave a talk at some point about the Kubernetes, like, how do we call this? Like the governance of the project. And Kubernetes has many different structures and also different levels of membership. So first of all, once you, let me find the page for that. Okay, so this is the community membership page. So if we look at this page, we see a table, and the first membership row you can basically receive in the Kubernetes community is to become a so-called member. This is an active contributor. This is a person that has sent a number of PRs already for different projects, and you can apply for membership. This page is going to instruct you how to do it, and then you become a member. The benefits of that are that you can now pretty much apply the LGTM label, which is /LGTM, to any PR that you like, which means that you're a member, you're a trusted person. You can review PRs and you can say that you can get a PR one step further into the merging process. Like the LGTM label definitely does that. Then you also have a reviewer. So the difference between a member and a reviewer is kind of is formal. A reviewer is a person that is a distinguished reviewer for a project. This person can be present in owner files, and I'm going to show you an owner file in a minute. An owner file is something that basically the owner file is a list of people that may be reviewers and approvers. So these are distinguished people that they have already participated in a certain project for a long time. They are participating, they're helping, they're reviewing, they're helping the contributors basically change the PR in the right direction. That's like the main responsibility. They can also hold the PR if something is not right. So this is a reviewer. They get automatically pinged by bots for a review, like, hey, you have to review this because you are in the owner's file. And the next row is an approver. The approver is someone who can do the /approve label. And this is a label that when it's added, and also when there is an LGTM and a /approve as well, a PR is going to be merged. But without an approve, the PR is not going to be merged. And usually the list of approvers is much smaller. These are like the folks who are like the most trusted people in the project. Those are the maintainers, or maybe not the maintainers, but those are the folks responsible for the changes to the project. So, and there is also the sub-project owner, and these are the folks that reside in a specific YAML file. You can click this and check this out. These are folks that are pretty much owners of a sub-project. So a sub-project can live in a separate repository, for instance, like Kubernetes/KEPs. And the sub-project owner in this case is Justin Santa Barbara. Justin is the owner of the KEPs project, and he's present in these owner files that distinguish him as an owner. And he, such people can decide that they can even overrule the approvers. Like, hey, this is not a good feature. Like, even if this PR is already approved, like, let's stop this, close the PR, go back to the drawing board and decide how to proceed. There's also, this page also has a lot of information, like how everything works, and should definitely have a read. Like, there's some interesting details, like the members can do also okay to test. If you're not a member of the Kubernetes organization, you have to wait for somebody to apply this command, and only then your PR is going to be tested against the CI that we have. Also, members can close issues and PRs. So let's have a look at the kubeadm owners files. Owner file. We only have one in this particular location. So we have approvers on the top of the document. These are the folks that are responsible for the approval of PRs against this particular section of the Kubernetes repo, that is kubeadm. And also we have a bigger list of reviewers. So if you graduate to a reviewer in kubeadm, the bots are going to ping you for review. And then at some point, you have to assign an approver as well. So if you assign an approver, the PR is going to be merged based on the LGTM and approved labels. And now let's have a look at some PRs, and then I'm going to get back to some of the the structure of the kubeadm code base, but only briefly. So let me close these. I have a bunch of useful links here. And I also want to show test grid, I guess, at the end. All right. So I have a link here. So this is this bookmark here is pretty much has these filters. So is the PR open, and is the area of the PR that is being in progress kubeadm? So area/kubeadm. This area label is being applied automatically by the bot. So every time somebody sends a PR for kubeadm in the KK repository for its Kubernetes, I click this link and I check for new items. And even if I'm not an approver, even if I'm not assigned to review this PR, I can still check this because I have the list. If something is interesting, I'm going to comment on that. So, all right, so these are some PRs that we have pending, and pretty much if you want to check some of the existing PRs, you can just use the same filters that I have. You can see some of the discussion that we have in the past. You can see some of the PRs that are problematic. We have some old PRs that we don't touch, but overall we try to address stuff pretty fast. On the other hand, kubeadm, like I said earlier, it's such a mature project that everything that is being touched can cause problems. So we try to be very careful on what we do, and we try to be careful in the changes. And when you send a PR for this repository, that's one of the reasons I told you, like, you have to have the issue first. And let me give you an example of a PR that I sent this, okay. This is a PR that I sent. So when you send a PR, and I guess the same applies to login issues in the kubeadm repository, please always follow the template. So the template is important because it provides us with the useful information. Like, why do we need this PR? Like, is there a related issue? Like I suggested, always log the issue first. Special notes, like, hey, I want to explain something important to you. Like, you can add special notes in here. This is also very important. This is a field that is being automated by our release tooling. So if you add a release note under here, and you say like kubeadm column, and you explain what this change is doing, like in the 117 release log, this particular sentence is going to be present. And remember to always add this under user-facing change. And also they recently added this. This is, you can link from here to an existing Kubernetes enhancement proposal. So you can link to the KEP from this particular field. And then you can, if you know which folks are competent in a certain area, you can even assign those folks. Like, hey, I'm going to assign Rafael for this. And there's a priority backlog because this is not a super important problem. And I can, I can add some of these labels that I think are appropriate. So the kind label is important. I can add the priority backlog because I can establish the priority for this myself. And then folks are going to participate in review. Something I wanted to add here, if you see some failures, have a look at these red crosses, the failed jobs, look in details. Like if something doesn't feel related to your PR, just type retest. You do it like that. So this is a problem that we have in Kubernetes. We have some flakes. And flake is basically a test is failing, but it's not really a problem. It's just occasionally, connectivity between a Google cluster and the internet can fail. So this is a temporary problem. So the way to solve it, when you see some failures like that, you can type retest, and the bots immediately start retesting this. But if something is really failing in the details, you can see like, hey, I have this kubeadm problems, and I send a PR of kubeadm. Maybe your PR is really, affecting the build process or, the end-to-end test signal that we have. So your change might be disruptive. So please have a look at the details and see if this is a problem. Going further into testing, I wanted to explain some of the tools that we have for inspecting test results. This is just informative for you. If you are interested in, if you have a background in testing, you should definitely contact me and we can get you on board into like the whole development process of end-to-end tests. But also, please go to the kubeadm repository. Let me open that again. If you go to the kubeadm repository, we have these docs in here about like how do we manage end-to-end tests. And this is a great page for you to understand how we do end-to-end testing for kubeadm. And this is pretty much the result. We have this. So this page is called Kates-test-grid. So this is test grid. Test grid is pretty much our visual resource for inspecting end-to-end test results. So in here we have like a lot of different sub-projects, and one of them is kubeadm. If we click in here, you can see some current running tests. So if something is red, it's currently failing. So this means we have to have a look at this, like what is the reason for this failure. Like we have some tests that are in blue. So those are pretty much passing. So you shouldn't care about those. But if something is red, and if something is important to the Kubernetes release, we have to follow back and see like when this started failing. And we look, there's a magic trick here, sorry. If you click and drag and release between the red and green, there's a pop-up here that tells you like search for changes. And you might get an indication. This basically compares some SHAs between a couple of SHAs in the Kubernetes repository. So if something changed in kubeadm, you can catch it. So why isn't there anything here? This means that something else changed. So it's not Kubernetes, so it's not kubeadm itself. In this case, my guess is that something changed in kind. So kind is one of the tools we use for testing. So we have to have a look at this. So let's go back to the structure of the kubeadm tree. I'm not going to talk about end-to-end tests a lot, but there's like, okay, let's quickly show how does a test failure look like. Maybe you might be interested into this particular area, but arguably this is probably one of the hardest things to do. When you get some failures in an end-to-end test, you're going to get these red boxes. If you click on the red boxes, you're going to get some like test result. And there's a massive file that is a build log. In this case, it's not that big; it's 1,000 lines. But if you click here on the failed part, you're going to see that something went wrong with this particular command. And if you click at the build log, you can then have a look at the whole log of the end-to-end test, and maybe if you understand like how this works, you can figure out like where is the problem. And you can search in this particular log for special words like fail or error, and it might get you some information. There's also a very important link here that is artifacts. So every time we run a test, after the job fails or succeeds, we dump some logs in an artifacts folder. And this is where you can check, the contents of every node in the cluster. Like here, obviously, we have 3 control plane nodes, 3 worker nodes. So you can click on some of those, and you can expect like, hey, what are the logs for the kubelet from this particular node? This is digging very deep into the development, and these end-to-end tests are complex, but they also provide us with complex signal so that we can catch problems in the development process. And we also have a bunch of these, we have something like 20 tests at least here for kubeadm. So let me go back to the kubeadm source tree. So this is something that ideally you should start looking at yourself. You start looking yourself, like, where should I even begin contributing to kubeadm? Well, first of all, kubeadm, you have to understand that kubeadm is a CLI tool. It has some parts that are a front end and some parts that are back end. And some parts are they are like mostly utilities, but they can apply to both. But maybe they still can be considered backend. But unfortunately, kubeadm has evolved in such a way that it doesn't really has a clear distinction of where the backend is. But we definitely have some of that. It's not completely, spaghetti mess with multiple, front end and back end portions mixed into the same files. It's not like that, but it's still pending for better organization. But for now, I'm going to quickly explain to you how does this project even work on the source code level. So given this is kubeadm is a CLI tool, it obviously needs something that is a command line section. And a common practice in Kubernetes is to name these sections as a folder that is CMD. So if you go in here, you're going to see the CMD folder. And now, if you're already a user of kubeadm, you're going to see all those files. Like, for instance, you have join, init, reset, token, version. These are subcommands of kubeadm. So you can click in those files and you can inspect what is going on. We also have some subfolders in here. So we have alpha. I spoke about this earlier. We have this alpha command that we care about. It contains some alpha features. We have some options. I believe this only contains helpers. Yes, some constants, things like that. We have phases. All right, I'm going to get back to this in a minute. This is very interesting. We also have upgrade. Because upgrade, by the way, this is being reworked right now as we speak. But upgrade is a collection of more subcommands because upgrade has so many subcommands that we decided to create a separate package for that. We then also have utils. And these utilities, they obviously apply only to the CMD part. So now let's look at the CMD phases. So if you have been following the kubeadm development, you've probably noticed that we added phases for pretty much a lot of our commands, including init, join, reset. So phases are a way to separate a certain process of the kubeadm workflow. And the goal of the phases is really to give you more power, give the user more power. You can execute a certain phase of the init process. I can give you an example. For instance, one of the phases in init are starting the kubelet. You might decide like, hey, I'm not going to start the kubelet at all. So let me skip this phase and I'm going to execute all the other phases. But then you have to understand how the whole init process even works. So if you skip a phase, you have to, if you skip the start kubelet phase, like maybe you might have to start the kubelet manually yourself. Otherwise, during init, you're not going to be able to move the control plane static pods because that is going to be the responsibility of the kubelet. And then you also have phases for join, which is pretty similar. It also starts a kubelet, but it's more reliable on the existing control plane node that already, the cluster is already formed. You can join using this command. And there is also reset and upgrade node phases. And we have these phases. We have this basically module in kubeadm that is called the phase runner, also developed by Fabrizio Pandini. This is the module that is responsible for running phases. So it is a common backend between all those commands. So init uses the phase runner, join, reset, everything. And in workflow, you can actually see some of the bits and pieces of this particular aspect. Like here is the runner, here is how we define a phase, and we also have some documentation here. All right, so this is about phases in CMD. Now let's have a look at what else we have here. So API, kubeadm has a configuration file. And this is it's both an API object, it's both a configuration file. So Kubernetes, follows this model of defining APIs. So we have a YAML document with a version, and also it has a kind, and it also has a group. So this is pretty much an API. But at the same time, this is a config. So how do we call this? The name for that is a component config. There is a whole working group in Kubernetes called Working Group Component Standard. You can Google that. The goal of this working group is to define how do components like kubeadm define properly their API objects, but API objects that are really configuration related. They're component config. So this is, first of all, I want to explain, if you're already a Kubernetes operator, the kubeadm configuration is not being managed by the API server as a direct API type. This is something that kubeadm manages. It loads this, it writes this to a config map, but also the user has to feed, same values in a file. And kubeadm then reads this file, loads this in memory, and creates a cluster based on that. So if you want to check more, you can click here and pretty much look at our docs. There's a very detailed explanation of how this works. Sorry, you have to click in one of these, V1 Beta 1 or V1 Beta 2. These are our actively supported types. So you can go in here and you can click doc. These are essentially Godocs, and it's pretty detailed. It gives you a lot of examples, like explanations of what is this, how does the kubeadm component config even works. And you can definitely check this out. I'm not going to talk about how do we do, what is the meaning of all those generated files and register and types. This is really deep stuff. But if you want to understand more about this, just try to have a look at actually, this is pretty complicated, but this is API machinery. This is the area of Kubernetes that is responsible for generating these conversions, defaulting functions, and everything. This is when a new API type is introduced, you're going to get basically. Let me open the register. Okay. So API machinery is really the area of Kubernetes, which is probably one of the more complicated ones. So the kubeadm API type has a group, and this is the group. It also, this one is a version, has a version that is v1 beta 1. And what this whole logic here is doing is it registers a schema with a group inversion, and then it enables some conversion. So I can feed any version to this version of any API version to this version of kubeadm, and kubeadm should be responsible for converting and understanding this version. I mean, that's all I'm going to say here, because this is digging really deep into some details. So my proposal is that you definitely should not start with the API area of kubeadm, but you can still use it, because that's we are making it easy to use, but kind of difficult to maintain. So we also have component config. Like kubeadm also deploys kubeproxy at the kubelet, and this is a package that is responsible for this particular area. We have plans to basically change this slightly in the near future, hopefully. This package is about constants. You know, we have different constants between Unix and Windows, and we have some unit tests as well. In here we have discovery. Now, discovery is an interesting package. This is the area where how do we discover a joining node? How does a joining node discover if there is an existing cluster? How does it validate if the cluster it wants to join is the correct one? Well, this is the package for it. And we support different types. So we support joining using a kubeconfig file, using HTTPS, and also using a token. And there's a little bit of an overlap here, because you know, you can still have pretty much bootstrap tokens inside a kubeconfig. But if you want more information on that, I suggest that you go on the page that is about kubeadm join. All right, so this page is going to, hopefully, I think it was here. All right, so here are the different options for how do we do different types of join using kubeadm. And there are advantages and disadvantages for all those. Some of those are less secure. So if you're interested, definitely have a look at this. This is what this particular package is all about. So what else do we have here? We have app. In the app folder also we have features. So this is pretty much, you know, Kubernetes itself supports feature gates. And if you don't know what a feature gate is, you should definitely Google feature gate and Kubernetes in the same search query. It's going to give you an example of what is a feature gate. And the story here is that the kubeadm project did not find the feature gate backend sufficient, so we created some. I believe this is pretty much a wrapper at this point. Yeah, we wrapped the existing feature gate support we extended a little. As you can see, we have support for a couple of feature gates at the moment. It's for core DNS. We also have one for IPv6 dual stack. I believe we should be removing the core DNS one at this point. Yeah, it's hidden. All right. So this is my explanation for this package. What else do we have? Images. So this is a package that is pretty much handling basically the formation of all the images that kubeadm needs. So let me clarify, like kubeadm, when you create a control plane node, kubeadm is going to pretty much start pulling images from the internet. And you can use a private local registry as well. But kubeadm by default starts pulling currently from a GCR bucket. So this is Google infrastructure where all those images for the API server, Hypercube, or the controller manager reside. And this is basically a package. The images package in kubeadm is responsible for the formation of the exact URLs for those images. And that's how we basically pull these images. All right, so we also have some unit testing here. What else do we have in this the code base? We have phases. Now this is we have CMD phases, and we also have root phases. So this is the backend for the phases. So if there is a phase that is used during the command line execution, this particular phase might call something from the backend. And the backend is pretty much this particular package. For instance, if we have a kubelet phase, and this is this backend for the kubelet phase contains some helper functions and utilities that we execute. And you have to look at this list, like what are these phases, like why do we need parts of it in this backend? So some of the names match the subphase names because we also have subphases for the phases. And have a look at this. This is how you're going to learn how kubeadm works pretty much. And then we have pre-flight. Like pre-flight should be probably one of the things I explained at the beginning in this code-based walkthrough. The pre-flight is something that we execute every time we run kubeadm init, join, or commands like upgrade. So basically, we perform a bunch of checks. We check if the cluster is in a healthy state, in the case of upgrade, for instance, or in the case of init and join, we check if this node, the machine where you run kubeadm, is in a healthy state. Like we check for a sane version of Docker. We check if the ports that kubeadm is going to open by starting the controller manager, for instance, is something. If it's basically the machine is ready for this. These are pre-flight checks. There are also different pre-flight checks, like checking. I believe we have a pre-flight check nowadays for how many CPUs do we have, because kubeadm on control plane nodes requires like two CPU cores. So this you can also have a look at these. These are the pre-flight checks we do. What else do we have? So we have a utils package. And this one is pretty big. It contains so many different utils. We have utils for our connectivity to an API server. We create this wrapper of an API client. We have audit log support. We have certificate utilities. We have utilities related to the kubeadm configuration format. We have I believe these some utilities related to cryptography, abstracting, ecliptic the ecliptic algorithms with RSA algorithms. So we also have dry run. We have etcd. We have init system. Init system is abstracting, I believe, the Windows services again, and also the systemd on Linux machines. We have kubeconfig utilities, customized utilities. These are so many different utilities that we have for different purposes. So that's pretty much it. This is my explanation of the existing code base. This is a subject of change because we have a tracking issue in the community/kubeadm repo that we want to organize this better. So this is going to change in the future. Maybe one day we might have only like API, CMD, and package. Package, like the whole backend is going to move there. So this is a subject of change. But again, if you want to contribute to kubeadm, join the meetings, follow our issue tracker, check the PRs that we do occasionally. Occasionally check the PRs that we send, like the discussion that we have. I strongly encourage, like, if you want to do something, like, just look for help wanted tickets, and if you want to learn more about the project, join the Zoom meetings of the kubeadm office hours, because we try to we have to have a time box discussion, so we use some complicated terminology, but also we try to oftentimes break down the problem into simpler terms for folks who are new to the project to understand. So feel free to interrupt and ask a question like, "Hey, what are you guys talking about? Can somebody explain to me like this topic?" I'm familiar with HCD for the past 5 years. I can help in this area. You're talking about an HCD bug. So this is my whole informational video about contributing to kubeadm. I really hope that this is useful for you if you want to get on board. Again, if you want to contact us, you can also join the mailing lists and also our SIG Cluster Lifecycle channel. And feel free to ask questions. In particular, for if you want to join discussion on how to use kubeadm, you can also join a channel that is called like #kubeadm. That's where all the users of kubeadm reside, and we also have some experts in there helping. So yeah, this is pretty much all I have. So yeah, if you have any questions, find us on Slack, join the Zoom meeting, and so on. All right, thank you. Talk to you later. Bye.